Is going to be our lecture video for January 5th. Go ahead, get out your notes, and let's get started. Our goal for today is to be able to describe patterns with rules and find the next terms. Why might this be a useful skill? Well, there are patterns everywhere we look, from art to finance. Being able to describe these patterns helps us analyze them and then make predictions. That is sort of the goal of creating a rule and identifying patterns. Is once you know what the pattern is, you're going to assume that that pattern is going to continue and then make a prediction about the future. Now, not every pattern does continue, but it gives you a starting place if you need to make a prediction. All right, so in your notes, I want you to do your best to sketch this pattern here. This is a dot pattern. And the rule for this pattern is we want to add one more dot to each row and column to grow the pattern. All right, once you've got this dot pattern sketched, you might need to pause the video. We're going to label a few things. One is often our rules, especially with dot patterns, will refer to rows and columns, so we need to know what's the difference between a row and a column. So this here is a column. Columns go up and down. And the way we can remember that is that columns hold up buildings. So this looks like it is the column of a building, like a post holding up a building. And then this right here is a row. Rows go across. All right, another thing that's important is that these are figures. Each of these collections of dots makes its own figure. We have to abbreviate that to just fig. And we always start counting our figures with figure 0. So this is figure 0. This is figure 1. This is figure 2, and so on. All right, we want to draw the next two figures. So figure 4, let's count up the dots. This one's got 1, 2, 3, 4, 5 in the first row. So we want to start with 1, 2, 3, 4, 5, and then add one more. All right, and then it's 5 tall. Now it's going to be 6 tall. So 1, 2, 3, 4, 5, 6. And then in figure 5, it's going to be 7 tall, 4, 5, 6, 7, and this bottom row will also contain 7. All right, I think this rule could be improved upon. It says add one more dot to each row and column. I think we should specify to the leftmost column and the bottom row, because you could think that each of these dots going up this column starts a new row as well, but these rows aren't growing, only that bottom row is growing. All right, so this is a dot pattern. This is also a growing pattern because the figures are getting bigger and bigger. Another type of pattern would be a rotating pattern. Here the rule is to take our figure and rotate it 90 degrees clockwise each time. So let's add into our note a quick diagram of the difference between clockwise and its counterpart, which is called counterclockwise. So clockwise, it is very self-explanatory. It is the direction the hands move around a clock. That's where it gets its name. And it is this motion. If you start up at 12 o'clock, you move to 1, then 2, then 3. Its counterpart is counterclockwise. And now, to draw this spiral, we'll think, okay, if I start at 12, I'm not going to go towards 1. I'm going to go the opposite direction around the clock, go to 11, then 10, then 9, and come back around. And that's counterclockwise. All right, this shape has been rotated 90 degrees clockwise each time. Let's see if we can continue that. So it's going from lying flat to standing up to lying flat to standing up. So we know the next one's going to be standing up. And then this dark part here is moved clockwise around 90 degrees, so now it's at the bottom of this rectangle. Continues again now to figure 1, 2, 3, 4, 5, 6. It's lying flat again, but that dark part has moved 90 degrees clockwise again to this position. So 90 degrees, we should take a quick note on our angle measures, because if we don't know what 90 degrees is, we might not be able to draw these figures. So let's just picture our rotation as taking a single point and moving it in a circle. Like this. So what would these different rotations be? So if you rotate around just a quarter of a circle, well, that's 90 degrees. If you rotate around a half of a circle, that's 180 degrees. If you go 3/4 of the way around, that's 270 degrees. And if you make a full loop, that is 360 degrees. Here, I want to change this so it's a little bit more symmetrical. Put my 90 degrees right there. All right, so that'd be rotating a point maybe around some sort of center. Now to rotate a full object, you just need to attach that point to a shape that goes through the center. And then that shape can be rotated around some center point. Notice rotating 360 degrees is the same as not moving at all. So 360 degrees is equal to 0 degrees in terms of rotation. You end up facing the same direction. Okay. Here's another rotating pattern, but it's a little bit more tricky. See if you can pause the video here and correctly sketch the next figure here. All right, I'm going to try and do this. So I notice like my black square here goes from the bottom left to the bottom right. So in order to do that, we must be rotating counterclockwise 90 degrees. So let's write down the rule for this. The rule is it's a rotating pattern, and we're going to rotate counterclockwise 90 degrees each time. All right, as we go from figure to figure, starting at figure 0, then figure 1, figure 2, can we get this next one? So that black dot went bottom left, then bottom right, then top right. Now it's rotating around to top left. So maybe I can start with that black square. Let's come over here. All right, the white square is always exactly opposite of the black square. So maybe we'll put that white square over there. Let's follow the diagonal line. The diagonal line is top left, bottom right. Now it's going to come up top right. So this diagonal line is going to go here. And with those features, I think I can now finish the shape so that it looks like this shape, but just twist it a little bit. Notice I could just, maybe in your mind's eye, turn this and it would overlap that shape exactly. Okay, so there's a lot of different ways to picture this. I like to just focus on individual features, making sure they're going to the right spots. All right, let's work on another dot pattern, but this time we're going to answer a few more questions about it. So here's your pattern. It starts with just one row and two columns. We'll call this figure 0. All right, in figure 1, each of those columns has gotten a little bit bigger, and in figure 2, each of those columns has gotten even a little bit bigger than that. So draw the next two shapes in the pattern. Let's do that. Maybe we'll come down here for that. So figure 3 looks like we've got columns that are 1, then 2, then 3, so now they're going to be up to 4. But the number of rows, well, the number of columns stays at 2. So the rows, we're adding a row each time. So that should help us draw these next two. So that one had 4. Now this next one's going to have columns that are 5 tall, or we could say it has 5 rows. All right, so what is the rule for this pattern? The rule, you can say it in a couple different ways. You could say make each column 1 taller each time, or add a row each time. You could say a row of 2 each time. There's lots of different ways we could say it. Write this pattern as a sequence. So here's another vocab word. That is, a sequence is a list of numbers. So we're going to boil down this pattern, this dot pattern, into just a list of numbers, which means we're going to lose information about the rows and columns and just keep the information about the number of dots. So here's our sequence. It goes 2, 4, 6, 8, 10. I'm just counting up the number of dots in each figure. What's the name for the sequence of numbers? So this is a very special sequence. Not all sequences have names, but this sequence is called the even numbers. It is all of the numbers that are divisible by 2. All right, will 15 be in the sequence? Explain how you know 15 will not be in the sequence. Because it is not even. If this pattern is only giving us even numbers, then it will never give us an odd number. All right. So, speaking of sequences, so we could also call those numerical patterns. We have 4 main types of numerical patterns or sequences. We can have adding patterns, where to get from one number to the next, you continually add the same amount each time. Should copy down this adding pattern here. You can have subtracting patterns, where we're continually subtracting the same amount each time. We can have multiplying patterns, where to get from one number to the next, you continually multiply by the same number. Here we're multiplying by 3 each time. And then dividing patterns, get from one number to the next. In a sequence, they're normally called terms, by the way. But to get from one term to the next, we're continually dividing by the same number. So what you're doing is the same each time, but the number that you're doing it to keeps changing. And then you just continue on using that same pattern, where the output from the previous step becomes the new input for the next step. All right, I'll embed a few more questions here, but that's the end of this lecture video, and have a good rest of your day.